Okay, we're starting with the Unit 1 test. The Unit 1 test covered objectives 2.2.1 through 2.2.3. All of those objectives have to do with analyzing the behavior of waves. The first objective was 2.2.1, which is analyzing how energy is transmitted through waves using the fundamental characteristics of waves, including wavelength, period, frequency, amplitude, and wave velocity. On your test, you had this diagram. I'm going to use this diagram to reiterate the vocabulary. First is a wavelength. The wavelength is the distance from one corresponding point on a wave to the next corresponding point on the wave. That could be crest to crest. That could be trough to trough. That could be this section, equilibrium on the downhill, to the next equilibrium on the downhill. Okay? Those are all considered wavelength. Wavelength is represented by the symbol lambda, and its units are measured in meters. Okay? That's wavelength. The next one is period. The period is represented by the letter T, and it's measured in seconds, and it is the time for one wave to pass a certain point. So, starting at 0 seconds and going for one complete wave, the period of this wave is 0.5 seconds. The other way you can write this is one wave over 0.5 seconds, which would equal 2 waves per second, which is the frequency. Okay? Period for this wave is 0.5 seconds. It takes 0.5 seconds for one wave to pass a certain point. Frequency is equal to 1 over the period, which is on your reference tables, which is equal to 1 over 0.5, which is equal to 2 hertz, which brings us to frequency. The units for frequency are hertz. Hertz is also equal to the reciprocal of seconds, so, or 1 over seconds. But if you're familiar with exponents, you know that a negative exponent means that you flip it to the bottom. So 1 over s is also equal to s to the negative 1. Does that make sense? Okay. So that gives us wavelength, period, and frequency. The amplitude is the distance either up or down from the equilibrium position. This line is the equilibrium position. So from the equilibrium to the crest or from the equilibrium to the trough is the amplitude, not from trough to crest. Like, don't go the entire distance. That's not the amplitude. That's actually twice the amplitude. Okay? And then the wave velocity, if you look at your reference tables, the velocity of a wave is equal to the wavelength times the frequency. The units for velocity are meters per second. We know that the units for wavelength are in meters because it's how long it is. We know that the units for frequency are hertz, which is 1 over seconds. So if I multiply meters times 1 over seconds, I get meters per second. Okay?